Assalamu alaikum. Today on 24th June 2021, I'm starting lecture number 2 for week number 13, and the topic of today's lecture is normal approximation to binomial distribution. How can we approximate a binomial distribution with a normal distribution? We can approximate a binomial distribution with a normal distribution if a certain criteria is meeting. I mean to say that not every binomial distribution may be approximated with a normal distribution. There is a criteria that has to be met before converting a binomial distribution into a standard normal distribution. What is that criteria? In this slide, the criteria is written as the product NP must be greater than 5. But I should say that internationally, there are two criteria that are to be met before applying this approximation. Number one, NP, that is product of number of trials and probability of success, must be greater than 5 as written in this slide. And in addition to this product NP, the product NQ must also be greater than 5. So before converting a binomial distribution into a standard normal distribution, we must identify or reckon that both products that are NP and NQ must be greater than 5. Now, how can we convert this binomial into a standard normal? To examine this procedure, we take one example. So let us talk about that particular example. Suppose if you are basically solving a problem that the probability of being a smoker among a group of cases with lung cancer is 0.6, while the probability that in a group of 8 cases you have fewer than, so you have to calculate the probability that in a group of 8 people, what is the probability that fewer than 2 are smokers or more than 5 are smokers. So in this problem, number of trials, that is n, is equals to 8. Probability of success, that is equals to p, is given by 0.6. And we are to calculate the probability of x less than 2 and probability of x more than 5. So if we do not apply any approximation to calculate this probability, what we should do, we will calculate probability of x equals to 0 and probability of x equals to 1, and then we will add up these two probabilities to get probability of x fewer than 2. Similarly, to calculate probability of x more than 5, we will calculate probability for x equals to 6, x equals to 7, and x equals to 8. And then we will add these three probabilities to get probability of x greater than 8. Now, other question is, what is the expected value of this probability distribution or this binomial distribution? So for expected value, we will calculate n into p. So n is 8 and p is 0.6. So n into p, that is expectation of this distribution, is 4.8. Similarly, to calculate the variance of this probability distribution, we will calculate the parameter npq, and then we will take root of this variance to get the answer of the standard deviation. So let us see that how they are doing this thing. So either you can use the Pascal triangle or you can use the probability binomial probability distribution formula to compute these probabilities. So for a plus b whole power 8, you can compute the coefficients from the Pascal triangle. The coefficients are 1, 8, 28, 56, 70, 56, 28, 8 and 1, and you can easily compute these coefficients using the NCX formula, that is 8C0 is 1, 8C1 is 8, 8C2 is 28, and so on and so forth. So for this problem, you can easily compute probabilities of x equals to 0 two probabilities of x equals to 8, because there were 8 persons that were examined, and out of the 8 people, we were to calculate the probability of x less than 2 or probability of x greater than 5. So now for probability of x less than 2, what we can do, we can add the first two probabilities, that is 0.00065 and 0.008. And for probability of x greater than 6, we can say that the probability is 0.21 plus 0.090 plus 0.0168. So if we are to draw the probability distribution diagram of this question, so this is the histogram representing the probability distribution diagram for the question, where there were 8 people examined, whether they smoke or whether they do not smoke. Okay, so now they represented the shaded region that is being asked from us. What was the question? To calculate probability of x less than 2 and to calculate the probability of x more than 5. So you can see in this slide that the two regions that are basically being shaded with lines, light blue lines, are the regions representing either probability of x greater than 5 or probability of x less than 2. So for probability of x less than 2, we will obviously add the first two probabilities of the table in the previous slide. And for probability of x greater than 5, we will add the last three probabilities of the table shown in the previous slide. Okay. Now to calculate expectation of this binomial distribution, we will simply calculate n into p. So 8 into 0.6 is the expectation, that is 4.8, or mean of the binomial distribution. Similarly, to calculate variance of x, we will calculate 8 into 0.6 into 0.4, and hence we will get the variance, and we will take the root of this variance to calculate the standard deviation, that is equals to 1.38. So now to convert this binomial distribution into the standard normal distribution, you can see that the probability distribution diagram is quite similar to the bell-shaped curve of the normal distribution, which is represented in this graph with a black pen. That is basically covering almost entire binomial distribution diagram. Yeah. So basically, normal distribution is designed for continuous random variable, while binomial is a discrete random variable. But under certain clauses, binomial distribution may be approximated with a normal distribution, and we can compute the binomial probabilities with the help of normal probabilities using the standard normal distribution table. Okay, so now if we want to calculate probability of x fewer than 2 with a normal approximation, what we should write? We should write mean equals to 4.8, standard deviation equals to 1.39, and probability of z equals to 2 is equals to 2 minus 4.8 divided by 1.39. That is, we will subtract the mean from the x value, and then we will divide the result with the standard deviation of binomial distribution. We were to calculate probability of x less than 2. So to calculate this probability using normal distribution, we will convert x into z. And how can we convert x into z? It is very simple. Subtract the mean of binomial from x and then divide the result with the standard deviation. So x was 2. We subtracted the mean from x, that is, we subtracted 4.8 from x, and then we divided the result with the standard deviation 1.39. Hence, x become z, which is equals to minus 2. Now, if you calculate the probability of this minus 2, it would be equals to 0.022. How can we calculate probability of z less than 2? It is very simple. you can open your calculator and then you will select the statistics mod in it. And then after selecting the statistics mod, you will open stats option. There will be 5 options. And I think the 5th option is the distribution option. So you will select the distribution option, and then there will be more 4 options. One is representing P, other is representing R, other is representing T, and there is one more option. I don't know what was that option, but you will choose the option with P. You will choose the P option, then you will press the P option. On the screen of your calculator, there will be written like P, capital P, bracket open. So now you will write 2 in it, and then you will close the bracket. When you will press the button P, what will happen? An alphabet P will appear in your calculator screen with a bracket open sign. After this bracket open sign, you will write 2, and then you will close the bracket, and then you will press the equal to button. And hence you will get the probability of z less than 2 as 0.022. So this is the procedure to calculate probability of z less than 2 from calculator. You can calculate this probability using the standard normal distribution table as well. How can we calculate this probability? Okay, let me just quickly open the book. Then I will tell you how to calculate this probability. So let me just open it. Okay, so this is the table known as the table for standard normal distribution. Now in this table, we need to find out probability of z less than 2. So what we will do, whether it was less than 2, less than minus, I think it was less than minus 2. Yeah, less than minus 2. So we need to calculate probability of z less than minus 2. So for this, we will calculate probability of z less than 2. So we will go towards the left, towards the right hand side from 2.0, and we will go downwards from 0.00, so that we can get the probability of 2.00. So points from 0.00 we will go downwards, and from 2.0 we will go towards the right hand side, and at the junction of 0.00 and 2.0 we will get the probability 0.9772. This is the probability of z less than 2. You must remember that this table is constructed cumulatively. That is, it gives the probability of z less than 2. It is not giving the probability of z equals to 2. It is giving the probability of z less than 2. So the probability of z less than 2 is 0.9772. But we need to calculate probability of z less than minus 2. So we will write probability of z less than minus 2 is equals to 1 minus probability of z less than 2. So the answer would become 1 minus 0.9772, and hence the answer would become, like in your slide, 0.022. Okay. So this is the procedure by virtue of which we can compute the probability of z less than 2. Now one more thing. In the question, we were required to calculate probability of z less than 2. But we computed the probability of z, we took the value of 2 now, but the question was probability of x less than 2. So if x is less than 2 and we are computing z for x equals to 2, then it would not give a very good approximation answer. Na? So to have a good approximation, to have a better result, what we do, we basically apply continuity correction. What we do, we basically apply continuity correction. Rather than probability of x less than 2, we will compute probability of x less than 1.5. Why 1.5? Because the question was probability of x less than 2. So if x is less than 2, then the upper bound of x must not be equals to 1.5, must not be greater than 1.5. So for probability of x less than 2, we will take x as 1.5. And then we will subtract the mean of binomial distribution from this x, and then we will divide the result with the standard deviation as 1.39. So for probability of x less than 2, a correct way, or we should say a more correct answer, could be obtained if we take x as 1.5 rather than 2. This correction is known as the continuity correction, and it has a lot of rules. Sometimes we need to add sometimes we need to add 0.5 in the given x. Sometimes we need to subtract 0.5 from the given x, and sometimes we need to take x as it is. So inshallah, in the next class we will share some examples with you that will explain when to choose with which continuity correction. Okay, so if we take 1.5 instead of 2, then the question becomes probability of z less than minus 2.37. Now, how can we compute probability of z less than minus 2.37? It is very simple. Number one, you can compute this probability directly from your calculator by selecting the statistics mode, then choosing the distribution option, then choosing the P option, then writing minus 2.37 up after the bracket opens symbol, and then closing the bracket and then pressing the equal to button, and hence you will get the result, that is probability of z less than equals to minus 2.37 as 0.089. Okay, so this thing you can calculate directly from your calculator, but if you are not capable of calculating this probability from calculator, or your calculator is not offering this function, then what we will do, we will share a table with you in the final exam, and you could calculate probability using this table, that is known as the table for standard normal distribution. So let us just calculate the probability from that table. So we quickly open the table. So this is the table, and now we need to calculate probability of z less than minus 2.37. So from 2.0 we will go towards the right hand side, and from 0.07 we will go towards we will go downwards. So if we go downwards from 0.07 column, and if we go right towards right from 2.0 row, then what happens that the junction of these two rows and columns is basically 0.9808. 0.9808 is basically we should go from 2.3 because it was 2.37. So we will choose the probability 0.9911. No, because we need to calculate probability of 2.37 now. So to calculate probability of 2.37, we will choose 2.3 from the rows and 0.07 from the columns. So at the junction of 2.3 and 0.07, you can clearly notice that the probability is 0.9911. Now this is the probability of positive 2.37. But we need to calculate probability of z less than minus 2.37. Now to calculate probability of z less than minus 2.37, we will write 1 minus probability of z less than 2.37, and hence it will become 1 minus 0.9911, and it will become 0.089. So this is the procedure by virtue of which we can calculate probabilities of Z from this table. You must remember this thing, that this table is valid only for standard normal distribution. What is standard normal distribution? A normal distribution with mean equals to 0 and standard deviation equals to 1. So that is the reason that we subtracted the mean from X and then we divided the standard deviation with the answer. Then we divided the answer with the standard deviation. Why we did this thing? Because we were to convert the binomial distribution into a standard normal distribution. Okay, so in the slide you can see that we subtracted we subtracted 4.8 from X and then we divided the answer with 1.39, that is standard deviation. Why? To convert X into the standard normal variable Z. And what is a standard normal variable Z? A variable following a normal distribution with mean 0 and standard deviation as 1. So you can see that our answer in slide is also 0.0089. Now coming to the next slide, there is another problem that we can calculate using this binomial normal approximation. Now the question is, if you are performing a cohort study and the probability of developing disease in the exposed group is 0.25 for the study duration, then if you are sampling 500 exposed people, what is the probability that at most 120 people develop the disease? Now, if you identify different parameters of binomial distribution in this question, then number of trials is represented by n and it is equals to 500 in this problem, while probability of success is 0.25 and probability of failure, that is 1 minus b, is 0.75. Now what is the number of successes? Here they are saying what is the probability that at most 120 people develop the disease. So in such scenario, X is 120 and less than 120. So this means if you want to solve this question using the binomial distribution, you need to apply the formula 121 times, because you will apply it for X equals to 0, for X equals to 1, for X equals to 2, so on and so forth till X equals to 120. So you need to apply the formula for 121 times, which is a very tedious, a time consuming, a lengthy procedure. So how can we avoid this lengthy calculation? Number one, we can program. We can write a, suppose, for loop for it. We will apply a counter for it. Then we will apply the formula for X equals to 0, for X equals to 1 till X reaches 120. Then we will terminate the loop and hence we will get the result as 0.323504227. But again, writing a program and then executing it, it will take much time. So if we convert this binomial into standard normal, we can give a single line answer. How can we convert this question into a standard normal question? First of all, we will calculate the mean of this binomial distribution. So mean is 125, which is greater than 5. Then we will compute NQ. And again, this NQ is 375, which is greater than 5. So we can say that this binomial distribution may be approximated with the normal distribution. Now to approximate this binomial question into a normal question, what we will do, we will compute the mean and standard deviation of binomial distribution. So here the mean is 125, while the standard deviation is 9.68. Now this question could be converted as probability of X less than equals to 120. So we will subtract the mean from 120 and then we will divide the result with the standard deviation. So now the question has become a question of standard normal distribution with Z equals to minus 0.52. So all we need to do is to calculate the probability of capital Z equals to minus 0.52. Now you can compute this probability either with your calculator using the statistical model, or you can compute this probability using the standard normal distribution table provided in book. So let us calculate the probability using the standard normal distribution table. So this is the table, and we need to compute the probability for Z less than equals to 0.52, less than equals to minus 0.52. So for probability of Z less than equals to minus 0.52, we will compute the probability of Z less than 0.52, and then we will subtract this probability from 1 to get the probability of Z less than minus 0.52. So for probability of Z less than 0.52, we will go towards the right hand side from the row of 0.5, and we will go downwards from the column of 0.02. And at the junction of 0.5 and 0.02, the probability is 0.6985. Now this probability is basically representing the probability of 0.52. Now to calculate probability of minus 0.52, we will subtract this probability from 1. So we will say that probability of Z less than minus 0.52 is equals to probability 1 minus probability of Z less than 0.52, that is equals to 1 minus 0.6985, and hence we will get the result 0.3015. Now you can compare this result with the result given in your slide. So you can see that in the slide the answer is the same, that is 0.3015. So that was basically the procedure to convert a binomial distribution into a standard normal distribution. First of all, we go for the criteria check. We will check the criteria whether it is meeting or not. If the criteria is meeting, then we will convert X into Z, and while converting this X into Z, we will take care of the continuity correction and some special relationships that a standard normal distribution offers. So inshallah, we will share the details of this continuity correction procedure and the special relationships for normal distribution table in the next lecture. So that was all from my side in today's lecture. If you want to ask any question, you can ask it right now. And if you feel that you have understood everything, then inshallah we will meet in the next class. Till then, take care and Allah Hafiz. जी, समझ आ गई आपको बात? फर्स्ट स्लाइड ये थी फर्स्ट स्लाइड जी। फर्स्ट स्लाइड में सिर्फ ये बताया हुआ था कि एक बाइनोमियल को नॉर्मल में कन्वर्ट करने के लिए NP और NQ को ग्रेटर देन 5 होना चाहिए। यहाँ सिर्फ NP लिखा हुआ है, लेकिन असल बात यह है कि NP और NQ दोनों को ग्रेटर देन 5 होना चाहिए। ठीक है, अगर आप कभी किसी कैम्ब्रिज, ऑक्सफोर्ड, एडेक्सल को फॉलो करेंगे ना, तो आपको पता चलेगा कि NP और NQ दोनों का ग्रेटर देन 5 होना जरूरी है। यहाँ पे वैसे उन्होंने सिर्फ NP लिखा हुआ है, ये स्टैनफोर्ड की स्लाइड्स हैं, लेकिन ये कि असल में NP और NQ दोनों का ग्रेटर देन 5 होना जरूरी है। फिर वो वैलिड ही नहीं होती, फिर वो अच्छे आंसर नहीं देती, उसमें काफी मतलब परसेंटेज एरर ज्यादा होता है। कन्वर्ट वो फिर भी कर जाएगी, लेकिन परसेंटेज एरर सिग्निफिकेंटली हाई होगा, तो फिर वो मतलब सही आंसर नहीं आएंगे आपके। ठीक है ना, ये बात है। ठीक है जी, और कुछ? चले इंशाल्लाह फिर आपसे नेक्स्ट क्लास में मिलते हैं, और इंशाल्लाह नेक्स्ट क्लास में हम नॉर्मल डिस्ट्रीब्यूशन को कवर करेंगे। ये जो हमने बाइनोमियल इस वीक में कवर किया है, ये फाइनल पेपर में 1 क्वेश्चन का वेटेज रखती है। इसी तरह से जो लास्ट वीक में हम नॉर्मल कवर करेंगे, वो भी फाइनल पेपर में 1 क्वेश्चन का वेटेज रखती है। तो आप लोगों ने इसको अच्छी तरह से, अगर अभी आप लोग मौजूद नहीं भी थे, अपने फाइनल ईयर प्रोजेक्ट्स की वजह से या किसी प्रेजेंटेशन की वजह से, तो मैं आपसे यही कहूँगा कि इसको डिटेल से सारा लेक्चर मेरा सुनिएगा, स्लाइड्स को सामने रख के, और फिर इंशाल्लाह आपको ये समझ भी आ जाएगा और फिर आप इंशाल्लाह ऐसे सवाल भी करने के काबिल होंगे। ठीक है जी, तो इंशाल्लाह आपसे नेक्स्ट क्लास में मिलते हैं। टिल देन टेक केयर, अल्लाह हाफिज़।